Hello everyone, this is Bukya Krishna, roll number 20951A2130, branch Aeronautical Engineering. So today I want to discuss about combinations of composite materials. Firstly, I want to discuss about what is a composite material. A material system composed of two or more physically distinct phases whose combination produces aggregate properties that are different from those of its constituents are called composite materials. Or two or more chemically distinct materials which when combined have improved properties over the individual materials are called composite materials, and composite materials could be natural or synthetic. Composites, a judicious combination of two or more materials that produces a synergetic effect. A material system composed of two or more physically distinct phases whose combination produces aggregate properties that are different from those of its constituents. To obtain a more desirable combination of properties involved in physical principle of combination action, they have low density and high strength. So, what is the importance of composite materials? So, why should we use composite materials? Because of composite materials can be very strong and stiff, yet very light in the weight, light to weight, and so ratios of strength to weight and stiffness to weight are several times greater than steel or aluminum. So, the composite materials have high stiffness, and they are very strong and they are very light, and the ratios of strength to weight and stiffness to weight are more than the steel and aluminum, and fatigue properties are generally better than for common engineering metals, and toughness is often greater than 2. By comparing with normal metals, the toughness of the composite materials are very high. Composites can be designed that they do not corrode like steel, so they oppose corrosion. Composite materials possible to achieve combinations of properties not attainable with metals, ceramics, or polymers. Properties of composite materials. In selecting a composite material, an optimum combination of properties is usually sought rather than one particular property. Fuselage and wings of an aircraft must be lightweight and be strong, stiff and tough. We use composite materials in fuselage and wings, so they are lightweight and strong and stiff, and they have high stiffness and toughness. Several fiber reinforced polymers possesses this combination of properties. Example, laser rubber alone is relatively weak, but by adding significant amounts of carbon black to NR increases its strength dramatically. One possible classification of composite materials. There are two types, that is, there are traditional composites and synthetic composites. Traditional composite means the composite materials that occur in nature or have been produced by civilizations for many years. Example, wood, concrete, asphalt. And the second type of classification of composite materials are synthetic composites. Modern material systems normally associated with the manufacturing industries in which the components are first produced separately and then combined in a controlled way to achieve the desired structure, properties, and part geometry. The components in a composite materials. Nearly all composite materials consist of two phases. They are primary phase and secondary phase. In primary phase, forms of the matrix within the which the secondary phase is embedded, and in secondary phase, embedded phase sometimes referred to as a reinforcing agent because it is usually serves to strengthen the composite. The reinforcing phase may be in the form of fibers, particles, and various other geometries. Matrix and dispersed phase. Matrix phase and dispersed phase. Matrix phase is continuous, and whereas dispersed phase is discontinuous and surrounded by matrix. So dispersed phase is surrounded by matrix phase. Functions of matrix. There are several functions which a matrix is embedded are associated. That is binds fiber, act as medium, protect fiber, prevent propagation of cracks. Classification of dispersed phase. The dispersed phase can be fiber particle, etc. Fibers. One of them are glass fibers, carbon fibers, aramid fibers. They are aromatic. and particles like metallic or non-metallic, and flakes like 2D particles, and whiskers like thin crystals with high impact ratio, example graphite, silicon carbide. Whiskers, thin crystals with high impact ratio, example graphite and silicon carbide, etc. Classification of composite materials by matrix. Ceramic matrix composites CMC. Silicon carbide. SiC SiC. Some material both same material both matrix and filler, but filler different form such as whiskers, chopped fibers or strands to achieve preferred properties. Fiber reinforced polymers FRPS. A PMC consisting of a polymer matrix made with high strength fibers. Polymer matrix materials. Usually a thermo setting TS plastic is such as unsaturated polyester or epoxy. Can be thermoplastic TB such as nylons, polyamides, polycarbonate, polystyrene and polyvinyl chloride. Fiber reinforcement is widely used in rubber products such as tires and conveyor belts. Disadvantages and limitations of a composite materials. Properties of many important composites are anisotropic. The properties differ depending on direction in which they are measured. This may be an advantage or a disadvantage. Many of the polymer-based composites are subject to attack by chemicals or solvents, such just as the polymers themselves are susceptible to attack. Composite materials are generally expensive. Manufacturing methods for shaping composite materials are often slow and costly. Thank you.